we've been working with naming compounds. They're called binary compounds, where you've got one element and another element that are chemically bound together. You know, we talked about that chemical marriage. They have become something different. So two elements combine together to make a different compound. So we look at lithium phosphide, and we've been writing those formulas. So how do we do that again? So we look at lithium here. Lithium's on the periodic table in group 1 here. Our alkali metals, we know that there's a +1 on that group. So then I write lithium Li. So we convert the name to the symbol. We put a +1 on top. And that phosphide, it's interesting. Well, we drop the last syllable and add IDE, or we drop off the last part of the name of the element and add IDE. So that's phosphide, but I know that that must come from the element of phosphorus. And that's our -3 column in the nitrogen group. So then I write the element phosphorus and a -3. And then I've got the correct symbols for both. And then I do the crisscross the charge method and simplify method. So the 1 would cross down here, but we don't write 1s. And then the 3 would cross down here. So our actual equation or formula would be Li3P. So that's lithium with phosphorus. And again, we call it phosphide because it is a compound. So again, that's just a review on how to write formulas for binary compounds. Binary mean made of 2 elements only. Now here's a binary compound that needs to be named. So Mg, I recognize that. That's right in this location here. I know that that name is magnesium. And this is O, and I know that that is oxygen over here. But I don't say oxygen, I say oxide, because remember, these are compounds. So this is magnesium oxide. So that's how I name. So our goal today, that was just a review on how to deal with binary compounds. It would be kind of boring if all we could do is put only 2 elements together in compounds. And plus we'd be kind of limited, right? Kind of like the English language. If all I could do is put 2 letters together, the words I could put together would be very limited. But we know that we can put many different letters together and form more complicated words. So we're going to do that, okay, with compounds. And one of the ways to do that is with what are called common polyatomic ions. A polyatomic ion is a group of elements that are together and they have a charge. Now, if we look at acetate, acetate is C2H3O2 with a -1. Okay, if all there is a minus in this chart, that means -1. Ammonium is NH4 +1. You might be familiar with carbonate before. You might have heard that. It's CO3 -2. Another one you might be familiar with is hydroxide, OH -1. And nitrate, NO3 -1. Or maybe a phosphate, you've heard that before. So PO4 -3. Cyanide is a really dangerous one. It's a CN -1. So this is a group of polyatomic ions. They are ions because they have a charge, but they're groups of elements stuck together, and it would allow us to make more complicated compounds. Let's practice a couple. Iron 3 cyanide. Well, iron is right here, Fe, and it says, oh, there's a Roman numeral on that, so we know that it's charged then. It must be +3. Remember that Roman numeral tells us the charge of all those elements on the periodic table that don't have one specific charge. And then cyanide, I see Cn is right here. Okay, but it's a -1. Well, I'm going to do something special with these. I'm going to go parenthesis, Cn, parenthesis, but I'm going to put the -1 outside. I want to do that to remind myself that the Cn is one group together and the whole thing has a -1. Now I'm going to crisscross charges. So I'm going to bring the +3, I'm going to bring the 3 down here. And then the 1 would go there, but again, we don't do 1s. And then simplify, well, that is the simplified equation or formula. So that's going to be Fe parenthesis, Cn, 3 outside. Now it's important to parenthesis that Cn because remember that whole group needs to have the 3 with it. Potassium dichromate. Well, dichromate is Cr2O7 minus 2. I see it right here on my chart, and it's a minus 2, so I know I'm going to have to put 2 outside of that. Potassium, again, is in my group 1 here. There's a characteristic charge of +1 for that. So then I'm going to go K with a +1. Remember, I'm going to parenthesis the whole thing, Cr2O7 minus 2. Try to make that look more like a 7. Now I'm going to crisscross my charges. So I'm going to bring a 2 down here, and then a 1 down here. Now remember, again, we don't bring the negatives or positives when we crisscross the charges there. And we don't write 1s. Okay, so there's our answer, K2. Now I'm not going to write the parenthesis again. You can again if you want to. Okay, I'm not writing it because the number 1 is next to that, so I'm not multiplying that by anything but number 1. So I'm not going to rewrite my parentheses. But again, if you do, that's fine. But anytime there's not a number written down here, you don't need to keep the parentheses there. Okay, what about ammonium perchlorate or aluminum perchlorate? Well, aluminum is Al. It's in our +3 column. So I'm going to write Al +3. Okay, now perchlorate. Okay, let's see. It's right here, ClO4, and that would be a -1. ClO4. And then I'm going to put a parenthesis around that, and a -1 outside. So I'm going to crisscross my charges, so I'll bring the 3 here. And then the 1 crosses there, but again, we don't write 1s. So our answer for that one, I'll write it over here, is Al ClO4. Okay, it's a 3 outside. So that's how you handle the polyatomic ions. Now you might be wondering, when am I sure I've got a polyatomic ion? When don't I have a polyatomic ion? Well, if it's an element, you'll find it on the periodic table, like chloride, oxide, sulfide, phosphide. If it's not just an element and it's a polyatomic ion, it'll be found on this chart. So it's just a matter of inspection. When am I given? Do I find it on this chart? If it's not on this chart, it's going to be on the periodic table of the elements. So remember, the name will have an IDE next to it. So this is cyanide. It's really actually on the chart here. You're not going to find cyanide on this chart, on the element chart. So it's just a matter of inspecting and doing it that way. Okay, now what about naming them? Well, naming them is quite easy. All you got to do is find, well, Li is lithium. It's located here, so I'm going to write lithium for that. Our metals never really change. You just find them on the periodic table. So there's our metal. Now Cn, well, again, there's 3 elements here, not just 2. So we're strongly suspecting that Cn is not just on the periodic table. It's going to be found here. Cn is right there. So lithium cyanide. So that's all you got to do, write that. NaOH, well, we hopefully are familiar with Na right now. That's sodium. Again, a group 1 element. And OH, and again, I see 3 elements here, so probably this OH is not just going to be on the periodic table. I need to search my polyatomic ion. Oh, I see it's got a name, hydroxide. And notice how I don't have to drop the last syllable at IDE on these. All of the proper endings are already listed here, like this is carbonate, chlorate, hydroxide. So there's no name changing going on with the polyatomic ions because the name change has already occurred. RbClO, okay, well, that's also in group 1. So that's rubidium. And then, I've got 3 elements total here, so ClO is probably on my polyatomic ion chart. And I see its name is hypochlorite. And that's how you handle formulas, okay, with polyatomic ions.